Okay, let's connect. So, in last session, we were speaking about different phases or different steps that we perform, right? So, we said we start with business objective because that will drive what we do, right? That will drive the data that we need, the process that we apply, algorithm that we will apply, the result that we will predict, right? So from there, we go to collecting the relevant data based on the business objective. Data will not be okay, will not be okay. When I say will not be 100% of the time, it will not be in the format that you want. Okay, so you have to pre-process the data. It's called processing the data, pre-processing the data. Pre because we are doing it before. We are doing before running the model. Okay, our main objective is to run the algorithm, right? Main objective is to run the machine learning algorithm, but we do it before, right? Now, as part of that, okay, we saw about how to handle missing values. Missing values can be handled one by deleting the data. Okay, if there is a lot of data in that column, okay, you delete the column. If there's a lot of data in the row, you delete the entire row. Okay, but then there are many occasions where you will have only like 1%, 2% blank data in a column or in a row, right? So, if you delete it, you are losing 98% of the data, right? So in such cases, what we do, we replace with mean or median, right? Mostly we replace with mean. If data has outliers, then we remove the outliers as well. Okay, and we treat outliers also similar to how we handle um, missing values, right? So outlier values could be correct or could be incorrect as well, right? So you have to handle it carefully. Then we spoke about feature scaling. Why do we perform feature scaling? What's the idea behind feature scaling? Why do you perform feature scaling? Tell me. So see, feature scaling, okay, we perform feature scaling because if the values in different columns, okay, that go as input to your machine learning algorithm, if they're in different range, okay, that means, let's say one is in double digit, other is in 5 digits, right? Now, it is not, the the one that has higher magnitude, right? One that has higher values will have bias, will create bias into the system in the model. Okay. So because there's higher value, right? It'll have a higher weight, right? And one with a higher weight obviously tend to uh, you know pull. And that's why we do outlier treatment. Okay. The reason we perform outlier treatment is that even though we don't want one outlier, okay, will try to disturb the entire equation, right? So we don't want that one column to have impact or will try to have more impact on the analysis, final analysis, right? So we say, okay, let's bring them to the same level. That's what we do in the scaling. Okay. In scaling, we do what is called as standard scaling or Z scaling. Okay. We'll see later. Okay. When we actually do it. Okay. So, so that's the reason. Then outlier treatment we discussed. Then we have canonical data. What do we do in canonical data? Canonical data, we again perform three main steps. One, encoding. Okay, mostly your data will be in text, so we encode. But encode is not good because the canonical values. Okay, we expect all of these values to be equally good or equally bad in a way, right? But what happens since encoding will have like 0, 1, 2, 3, 4. Again, same problem like scaling. The one with the 4 will have much higher impact. Okay, since all the categorical values are same, okay, in see, when we enter into the model, like for example, age and salary that we were talking about, okay, maybe salary might have more impact on the machine learning model. Okay, maybe north might have more impact on machine learning model, but that should be decided by the model, not by us. Okay, you should not, you know, give higher value. What if is has more impact, right? So that will be cancelled out, isn't it? So that's why, you know, the the input to the model shouldn't be like that. Okay, input of the model should be such a way that you give equal weightage to all the columns, okay, and all the values in a categorical value. So we do encoding and then we do column transform where we'll convert these columns into multiple columns, and then they will delete one of the columns, okay, to avoid dummy variable trap. Okay, so we delete one column. So these are three steps we perform on categorical values, and these are the four main steps that we perform, okay, on pre-process feature scaling. Okay, apart from that, I don't think you will come across any other thing, but yes, okay, you have to make sure that the data that goes into analysis is free from any error, any bias. Okay, step number 4 is exploratory data analysis. Okay, exploratory data analysis is about creating different plot, different graphs, different visualization, okay, different tests that we discussed yesterday, like correlation and um, uh, uh, okay, okay. So we um, we only spoke about correlation, right? So we will see. So in EDA, okay, we try to find out the relationship between, okay, we try to find relationship between, okay, two variables and see if really, okay, if you know, one value impact another value or not, right? So okay, so now um, um, when you have complete understanding of the data, that's when you go and you know, you go ahead and build the model, right? In building the model, first thing again we do is, okay, first thing again we do is divide the data set into train and test. Why do we divide data set into train and test? Why do we do why do we divide it to train and test?
To check the impact,
Impact of.
impact of variables on each other.
Mhm. See, the perform we do is not because to that we do in EDA. Here we want to see, when I said we have multiple algorithms, right? When we say we have multiple algorithms, now which algorithm is best, right? So one thing is
Okay.
based on the why we know, okay, whether it is regression, classification, clustering, okay, which is good. But within regression, we have, again we said we have multiple algorithms, right? So within this, we have multiple algorithms, and you know, which algorithm within multiple algorithms will have correct impact, or we have you know, is able to make correct prediction, right? Here ultimately we are going to predict only using machine learning. That's why we use machine learning. So if you apply 10 algorithms, all 10 algorithms will make some prediction, but which out of those 10 is you know, is right? So we divide into training and test. Generally 20 to 30% data we take and we hide for test, then we say, okay, this is the algorithm 80% data you take, you learn from this 80% data. Okay, we say you learn from this 80% data. Now, then we perform test. Okay, we will test it on the 20% data and see which algorithm is correctly predicting. Okay, so that's why we have to divide the data into train, test, and test set. Once you are done, then you run the model. Okay, then you
Run the model.
yes. Okay, now after you run the model, okay, you will evaluate the model. Right now, because we need to know, okay, which data set has done well. Okay, so you have different metric. Okay, now this metric, okay, I told you, right, metric. Okay, so you run the model on the by training, you train the data, and now you run it on the test data. After running the test data, okay, you need to measure the performance of each algorithm on the test data. So you have different metric. Okay, so here your is based on regression or classification. Okay, you have different metric to compare. Okay, you have different metric to compare. Okay, so regression we use things like MSE, RMSE. Okay, mean squared error, mean squared error, or your RMSE, root mean squared error. Okay, we'll talk about this and many other. Right? Okay, we have R square. Yeah, one important is R square. So in fact, RMSE and R square, these two are enough. Okay, then you have here in classification, you have you know, we say confusion matrix. Name itself says confusion matrix. Okay, but it is not very much confusing. Okay, we use confusion metric and we create like accuracy. Okay, sensitivity. We'll talk about all these things when we go to classification. Okay, once you evaluate the model, you select the best model. Okay, select the best performing model. Okay, then finally you deploy. Okay, now you know that which is the best model, then you will deploy it. Performing model. Then you deploy this model, right? That means, okay, I found out. Now, so this is one to, so these are the main 7 steps. Okay, these are the main 7 steps, and this is what you need to perform as a ML scientist. Okay. Now, again, this is not the end. Okay, again, you come back and again you revisit and make sure that algorithm that was performing well 3 months back is also performing well after 3 months as well, isn't it? So, okay, it can change, maybe, because the nature of data has changed and things like that. So it can change. Okay. Now we perform the tests, hypothesis test. What is hypothesis test? Hypo, hypothesis test. So I told you, okay, when we make prediction about anything, okay, when you make prediction, you made the prediction, but how confident you are about your prediction. Okay, if you ask me, okay, if you tell me, Swapnil, do this thing for me, so I did this. Okay, now you ask me, how confident are you that you have done correctly? I'll say I am 10% confident that I did correctly. And what will you do? Will you take my work and go ahead? No. If I tell you that
Yeah.
I'm 10% confident, then you'll say, okay, sorry. Then let's redo. Let's rework. Let's sit and redo. Correct? If I tell you I'm 99% confident, then you'll get more confident about the work and you will take it and you'll move ahead, right? So hypothesis testing is about confidence. How much confidence have you on the work that you have done, right? So if I tell you age has impact on win, the yesterday's data that we saw, right? Not yesterday, last session we saw the data set, right? The data that we read. Okay, it has age, I mean salesperson. So it had region, salesperson, quotation, and impact win or loss, right? So I tell you age impacts uh, win by 5%, 10%. Then it's okay, then remove it. I'm not interested to carry that variable. If I tell you, quotation impacts Y with 90%, 95%, it's okay. Let me take it. Okay. Generally, okay, we go with 95% confidence minimum. If it is not 95% confidence, we remove it. Okay. But how do you measure it? Okay. So we tell you that for any test or any experiment, first we start with the aim, right? So you have to make an aim. You have to write an aim. Generally, we write, okay, that is called, okay, so with the aim is called as your um, null hypothesis. Null hypothesis is the starting statement, objective, basically objective. Okay, and opposite of this, okay, is called alternate hypothesis. Hypothesis. This is like opposite of null hypothesis. Okay, as it says, alternate. Okay, alternate of null hypothesis. Okay, so null hypothesis written as H0. Okay, null hypothesis, we represent it by H0, hypothesis 0, null, and then alternate hypothesis is as H1. Okay, so H1 is opposite of H0. So if I tell you that, quotation has generally null hypothesis talks about no impact. Okay, okay, it talks about no impact. So we say that quotation will have no impact on win or loss rate. Then you perform the test, okay, and based on the test, okay, you accept or reject the null hypothesis. You start with null hypothesis, and we at the end we accept or reject. Accept means yes, there is no impact. That means do not include that column in your analysis. No, no, no. Okay, there is an impact. So we reject the null hypothesis, right? So we accept or reject the null hypothesis. Okay. So there are different tests that we perform. If it is, okay, your numeric to numeric, output is number, and okay, the y column is number, and your input is again number. You want to see if age impacts on the salary. Let's say if your objective is to find salary, does age impact salary, right? Does numeric column number impact number? Okay, this type of test is called as Z. We perform Z or T test. Okay, T test is performed when data set is very small. When you have 20, 30 rows, we go with T test. Otherwise, we go with Z test. Okay, so this is example. Okay, does salary or age impact salary, or salary is impacted by age or not? Okay, so when you have to find the relationship between two variables, two numeric value, okay, okay, we use this test. Then we have chi-square test. Chi-square test. Chi-square test, okay, okay, again, same thing, whether there is impact or not. But to do this, okay, when we have both values as categorical value. Okay, when you have both, categorical, if both are categorical, okay, so does region impact win or loss rate or not? Region is also categorical and this has also categorical, right? We use chi-square test. Okay, then you also perform what is called as um, simple hypothesis or composite hypothesis. Simple versus composite. Composite will have a range. Okay, composite hypothesis, okay, will have a range. So if I tell you, okay, if I'm saying that my sales, my average sale is $1,000 per hour or per day. My average sale is $1,000 per day. Now my average sale is $1,000 per day. It's a numeric value, right? I'll be using Z's test, but again this is simple hypothesis because I'm talking about one number. Okay, but if I'm saying my average sale is between 900 and 1,000, okay, so if I tell you that, so and you prove it, you have to prove me either correct or wrong. Okay, you will ask me different data, I perform the different test, and you will show me, you will tell me that what I said is right or wrong, correct? So you specify the range here, okay, in the problem statement. My average sale is between 900 to $1,000. That becomes your sale. Then we have one tailed and two tailed, right? What is one tailed and two tailed? What is one tail and two tailed? See, we discussed the other day, right? When alternate hypothesis can have two values. Okay. When I say, okay, age has no impact on salary, let's say. Okay, so that is age has no impact. That is null hypothesis. But if null hypothesis is wrong, when null hypothesis is wrong, that means it says age has impact on salary. Okay, that is what we talk about. But does it negatively impact or positively impact? Okay, so higher the age, your salary will be lower, or higher the age, your salary will be higher. So you have two tail tests, left side, left tailed and right tailed. Left tailed is about lower, right? Okay, on the lower value. So if your age is higher, you have lower salary. That is left tail. Right tailed is higher. So instead, another example that we took was, if you water the plant, there will be impact on the growth of the plant. So will the growth will be slow, okay, or will it be faster, right? Slow is left tailed, right tailed is faster. So let's see. Generally, what we do is, okay, H0 we say no impact, right? So no impact means your mean is equal to zero generally, right? No impact. The mean is zero. Average is zero. It is not increasing, decreasing. Okay. H1 left tail. Okay, that means there will be a negative impact. Okay, your mean is will be less than zero. Left tail. This is your left tail, right? So you have two tail means left tail and right tail. Similarly, and this will happen when you reject the null hypothesis, right? Null hypothesis is only one. Okay, right tail is when growth is faster than average. Okay, so if you do not put a plant and growth is, let's say, 1 inch every month, if you water the plant, it has to be more than 1 inch, or it will have should be less than 1 inch. Okay, that's what null alternate hypothesis. If you water the plant also, if it is same 1 inch per day, then there is no impact of water on the plant, correct? But if it is more than 1 inch, then we say we reject null hypothesis. There, no, there is what is the impact of water. Even the growth is less than 1 inch. Also, we say null hypothesis is wrong, right? There is impact of water on plant growth. What is that impact? Positive impact. Okay, it grows faster than 1 inch. What is the impact? Less than 1 inch. Growth is less than 1 inch. Okay, growth is less than 1 inch means it's left tail, and when growth is more, it is right tail. Then we come across, now see these things, what we are doing, these things are the model will automatically handle. Okay, but we need to understand a little bit of these things. Okay, model will automatically handle, but what the final decision you have to make as part of model analysis is this: level of significance. Okay, level of significance talks about, okay, we will run some model, we get some output. Should we accept this output or not? Ultimately, okay, all the tests, all this are fine, but now if my model says that there is an impact, is that impact worth talking about? Is it worth accepting? That is called level of significance. Here you will come across alpha and p value. Okay, you'll come across alpha value and p value. Okay, alpha value talks about actually the level of significance. Okay, oh, generally we say, right, I'm 90% sure tomorrow is going to rain. I'm 70% sure it's going to rain tomorrow. So you are saying that there is an impact, but you are not very sure of the impact. Okay, alpha value talks about how confident you are, also called as confidence interval. Okay, how confident you are. Okay, so alpha value talks about how confident you are, and here, okay, you will talk about, okay, percentage in terms of your confidence. Okay, so what we do, okay, we generally take 95% as confidence interval. Okay, generally, okay, 95% is treated as right. So sometimes you will be 90% and sometimes 95%, or sometimes even if you want to be very strict, you will say 99%. So generally 90, 95, 99% is treated as the confidence interval. But as I said, we are more interested in 95. 95 is generally, if they don't mention, then we take 95% as confidence interval. When we don't mention, then we take 95% as confidence interval. That you have to be 95% sure. Okay, what is 95%? If you remember, 95% is your 3 sigma, correct or not? Okay, so you are at least 3 sigma confident about your value. Okay, so we go with 90. That's the interval. So 95% means you are rejecting the tail, which is like 2.5 on the left percent, 95%, right? So 95% is equidistance from mean. So when you take normal data, okay, we take equidistance from mean, and left side 2.5% we leave out. Okay, so generally this is 95%. Okay, but they might say, okay, 90% or 85% or 99%. Okay, so if they mention, you have to go with it. Okay, which is fine. But then, okay, p value, okay, is derived based on your test and based on alpha value. Okay, so generally if p value, okay, is less than 0.05, that is the 95% point less than, so what is left is 5%. Okay, so if I take alpha value as 95%, that means p value should be less than 0.05, which is opposite of alpha, right? Alpha is 95, then 5%. If alpha is 90, then 10%, or 10% would be 0.1. If p value is less than 0.05, we reject null hypothesis. Otherwise, we accept null hypothesis. Okay, what is accepting null hypothesis? I'm asking a question. What is accepting null hypothesis?
Starting statement.
What is the starting statement?
Objective.
No impact. Okay, generally no impact to the starting statement, right? So if there is no impact, then there is no need of doing all these experiments, right? If attending this class, if it is no impact on your machine learning knowledge, right? Okay, so your test will be, okay, attending this class will not improve my machine learning knowledge, will not have any impact on my machine learning knowledge. Now, if this class does not have any impact on your machine learning knowledge, then why should you attend the class? Correct? That is null hypothesis. So null hypothesis, if p value is more than 0.05, then with 95% confidence, you cannot say that this class is effective to me. So there is no need of going ahead. There is no need of going ahead, no need of performing any test. Correct? But if this null hypothesis is rejected, alternate hypothesis is accepted, that means there is an impact of this class on your knowledge. Okay. Now, okay. So some cases it's fine to know there is an impact. I told you, right? So when you see, okay, when you talk about categorical only chi-square test, okay, if true, okay, or let's say north zone. If north zone have 50 values, which is like win, and only 5 values as loss, right? And you get p value, okay, equal to 0.005. Now, when you get p value 0.005, what does that mean? It means that, okay, null hypothesis rejected. What is null hypothesis in this case? Null hypothesis is rejected. What is the null hypothesis in this case? Null hypothesis in this case is that north zone has no impact on win and loss. Okay, so p value is 0.005. It is less than 0.05. That means we reject that null hypothesis. So what we accept is no, north zone will impact win and loss. Okay, so will impact. Now, is it impacting win or loss? The two-tailed test, we know we are an alternate hypothesis, we accept it. But alternate again has two values. It will impact either win or loss. So you see here, win is more number, right? So obviously, north zone impacts win more than the loss. So one-tailed would be in this case that north zone impacts win more than the loss. If it was 50-50, you would have gone p-value very high, almost like 1, right? 1 or 0.9 or something. Okay, we would have rejected the alternate. We have to accepted the null hypothesis that north zone has no impact. If north zone has no impact, we remove it, right? Okay, it has no impact, so why should we carry it? Why should we even bother to talk about it? Isn't it? That's how we decide whether to include the column or not, whether to accept the test or not. These are all part of your model analysis. Okay, so with that we end our theory discussion about model building. Tomorrow, okay, when we meet, we'll talk about data cleaning. Okay, we haven't done the data cleaning. We will do the data cleaning. We'll do all those 4-5 steps that we have done. Once we do those 5 steps, then we will go to our first algorithm. We will do linear regression. We'll start with the regression first. We'll do our regression. We will do all these seven, not seven, all the. So first step, objective, we understand. So we will do objective, get the data, and we will do till step number 6. Deployment, we are not going to do tomorrow, right? Deployment we'll do. That will be our last, very last topic where we say, okay, this is how you deploy. Okay, that will be the end of our discussion. That is the last most class. But 1 to 6, we will see with the regression algorithm tomorrow, if we get time. Okay, first we have to do the data cleaning. Now that we understand all the theory, it is just coding. Coding should be faster, right? And then we can talk about linear regression also tomorrow. Is that fine?
Yes. Yes. Yes.